Welcome back, or maybe you didn't even watch the last video. But anyway, we are on problem number 15. 15. The Acme Plumbing Company will send a team of 3 plumbers to work on a certain job. The company has 4 experienced plumbers and 4 trainees. So 4 experienced and 4 trainees. 4 trainees. I spelled it right. If a team consists of 1 experienced plumber and 2 trainees, how many such teams are possible? So we're going to send 3 plumbers, right? 3 plumbers. So it's 1, 2, 3. And one of them has to be experienced, right? And then these are inexperienced. These are trainees. So this is the team, 1 experienced and 2 trainees. And now we're going to have to pick from a set of, let's say, we could pick from a set. Let's say my 4 experienced plumbers are plumbers A, B, C, D. These are experienced. And let's say my trainees are E, F, G, H. So these 4 are trainees. So how many different experienced plumbers can I have heading up the team? Well, there's 4 possibilities, right? So there's 4 different people I can stick in here. 4 choices or 4 possibilities. Now, independent of who I put into the experience slot, how many trainees, let's say this is trainee slot 1 and trainee slot 2, not that there's a difference. So now if I'm picking for who can go into trainee slot 1, how many choices do I have? Well, I have 4 choices because none of them have been staffed yet. So I can put 4 people here. No, not 4 people. I'm putting 1 person, but I can pick 1 of 4. So there's 4 possibilities here. Once I've already filled trainee slot 1, one of these people are going to disappear. Then the set is going to be 1 less, right? There's only going to be 3 trainees left once I filled slot 1. So how many trainees can I put in slot 2? Well, there's only 3 possibilities I can put because I already stuck 1 in slot 1. So there's 4 possible experienced people, 4 possible choices for trainee in slot 1, and then since 1 trainee will already have been staffed in slot 1, there's only 3 choices for slot 2. So it's 4 times 4 times 3. So what is that? 4 times 12, which is 48 possibilities. Next problem. And the trick here is just realizing that once you staff one of the trainees, you only have 3 left that you can put in the other one, in the second trainee slot. Next problem. Problem 16. All right, we got some circles going on here. Let me draw a circle. So they have one circle like that. And then they have a bigger circle that looks something like, oh, I don't know if no, let me undo that. Edit, undo. Okay, let me see if I can make it more even. That's pretty good. Pretty good. Okay, and let me fill it in with a pleasant color. All right. The figure above consists of 2 circles that have the same center. If the shaded area is 64 pi, so the shaded area is 64 pi. Shaded area is 64 pi square inches, and the smaller circle has a radius of 6 inches. So the smaller circle has a radius of 6. So that distance right there is 6. What is the radius in inches of the larger circle? So we want to figure out, radius of the larger circle. Let's call that, I don't know, let's call radius of the larger circle, I'll do in this green color. Let's call that x. So what's going to be the area of the shaded circle? Well, how would we figure it out if we knew the radius of the larger circle? What would be the area of the large circle? Area of the large circle minus the area of the small circle is going to equal 64 pi. Right? Because if the whole thing was filled in mauve or whatever color this is, then it would just be the area of the large circle, but we're subtracting out the area of the small circle to get the mauve region. So what's the formula for the area of the large circle? It's pi times its radius squared. So we're already set that radius to be equal to x, so it's pi x squared, and that's what we're trying to figure out in this problem, minus the area of the small circle. What's the area of the small circle? whose radius is 6, so it's pi r squared, so it's pi times 6 squared. And that is going to equal to 64 pi. And just to simplify things, we can just divide both sides by pi just to get them out of the way. So this, all the terms, you can get rid of the pi. But you don't have to do that. That just simplifies things for my simple mind. So we get x squared minus 36 is equal to 64. Add 36 to both sides, you get x squared is equal to 100. So x could be equal, if you just solved it, it would be plus or minus 10. And of course, a radius can't be negative, so it's plus 10. So x is 10, or the radius of the larger circle is 10. Next problem, problem 17. 17. If p, r, and s are three different prime numbers greater than 2, p, r, and s, let me just write them down, p, r, and s, three different prime numbers greater than 2, and n is equal to p times r times s, how many factors, including 1 and n, does n have? How many factors? This is a good problem. So let me put it this. This is essentially the prime factorization. This is the prime factorization of n, right? And we want to know. Oh, we want to know how many positive factors, including 1 and n, right? So what are all of the factors here? So if we just made a factor tree, obviously 1 times. Let's make a combination of all of the numbers that can, when I multiply a pair, can equal n. So 1 times n is equal to n. Another number that would equal n is pr. Pr times s would also equal n, right? Because obviously p times r times s is n. So p times r times s is n. But I'm saying p times r is a number, right? Hopefully that makes some sense. Similarly, we could say that p times rs is equal to n. Same logic. And I'm saying r times s is a number, right? It's some number. And then finally, we could say that sp times r, sp, where the sp is a number, is also equal to n, right? So all of these numbers that I said, 1, 2, 3, 4, 5, 6, 7, 8. All of these numbers are factors of n. So that's how many factors there are. There are 8 factors, including 1 and n. If this seemed a little bit abstract to you, try it out with some numbers. Let's say actually that's the best way you could do it if this was too abstract. You could say, well, what if p is 3, r is 5, and s is 7? Then what is n? Well, n is going to be 15 times 7. So n is 15 times 7. What is that? 70 plus 35. N is 105. So if n is 105, this is 1 times 105. PR, this would be 15 times 7. This would be 3 times 35. Is that right? 5. Oh, no, sorry. 85. No, sorry. 5 times 7 is 35 times 3. 35 times 3. 35 times 3. Oh, right, it's 105. Right. So we would write 3 times 35, and SP is 21 times 5. So those would be the actual numbers. So hopefully that makes a little bit more sense to you. But this is the way you could do it in a general way. It looks like I'm running out of time, so I will do number 18 in the next video. But this is a little bit of a non-intuitive problem. Just remember, this is the prime factorization, and then you can construct its kind of what I call the normal factorization. You can construct that by just taking combinations of the prime numbers. And hopefully the actual numbers make a little bit more sense to you. See you in the next video.